All right, so this is a simulation involving a table, and there's a pulley right over here on the edge of the table, and it's frictionless and low mass, and so we have a mass right here. Call that guy M1, and we'll just say it's 2 kilograms. And there's a string attached to it that goes over the pulley, and it's attached to a second mass down here. Oh, you know what? Let's make it 2 kilograms. And then what we're going to say about this surface right here is that there's no friction. So, two questions here, okay? When we release the system from rest, they're both going to start moving. This guy over here is going to move down, and the mass on the table is going to move towards the right, and they'll be accelerating. And using Newton's laws, we want to figure out what is the acceleration. I can barely spell. What is the acceleration, and then also what is the tension in the string? So, yeah, and again, this configuration of masses and pulleys and strings, it's called an Atwood machine, because apparently some guy named Atwood invented this, although I think he didn't. In any case, it's a basic physics problem that requires a little bit of understanding of Newton's laws of motion. So to get the acceleration, so there are two ways to do this problem. One way is to draw a free body diagram of each of these masses, because they're a mass here and a mass there, and so we make a free body diagram of each mass separately and write out Newton's second law for each one. And we'll have two equations and two unknowns, and we can solve those using algebra. So let's do this. First of all, let's look at this guy. All right, M2, it's 2 kilograms suspended by a string, and it's free to start moving. So I'll draw that down here. All right, so there's M2, it's 2 kg. I think, did I say 2 kilograms? Yeah. And so what are the forces acting on that mass? It's hanging over the edge of the table. Well, there's one thing connected to it, that's a string. And the force in a string is called tension. And the other force acting on it is gravity. That's the force of gravity the Earth exerts on it. And we've talked about this. The force of gravity is equal to mg. And if you wanted to, at this point, yeah, we could go ahead and figure out what the value of that. Since it's 2 kilograms, and little g is the acceleration of gravity, that's 10 meters per second squared. And so all that turns into, well, the numbers 2 times 10, that's 20. And a kilogram times a meter per second squared, we've talked about, that's called a Newton. So there's 20 newtons acting down on this thing, 20 newtons of force. And then up here, T, we don't know what that is. All right, now I'm going to write down Newton's second law for this mass. And that is net force equals ma. And we've been talking a lot about how to write these expressions down here. So if it's accelerating downward, then the way we need to write out the net force is going to be mg minus t. is MA. Now we can fill in the numbers, okay? So mg, we already figured out that's 20 newtons. And we don't know what T is, so I'll just leave it as T equals, and the M is 2 kilograms. But I don't know what A is. I'll just leave it as A. So there's one equation. And that's the equation of motion for the mass hanging over the edge on the string. Now I'm going to make a free body diagram for the mass that's on the table. All right. So here's the table. And this guy is sitting on here. I believe it was also 2 kilograms. And we're going to ignore friction, so there's no frictional forces. So we want to draw a free body diagram of this guy. So let's see. Well, there's the force of gravity acting on it. mg, it's 20 newtons. Also, the table is pushing up on it. That's why it doesn't sink into the table. That's called a normal force. And in this case, because it's not accelerating up or down, that normal force has got to also be 20 newtons. And then the third force acting on it is the tension in the string, T. So now, when we write Newton's second law for this guy, well, we write net force equals ma. The net force is just this tension in the string. These two forces, this guy and this 20 newtons, they're not relevant to the mass that's on the level surface here. So you don't need to include those. It's just T equals ma. So T is equal to, well, the M is 2, and A is A, and I don't know what that is. Yikes. So now you have two equations. One of them says that 20 minus T is equal to 2A. The other one says that T is equal to 2A. Let me write those two guys down here so you can see them both all together. So 20 minus T is equal to 2A. And the other equation that's relevant is T equals 2A. How do I want to solve this for either T or A. So how do I do that? Big question mark here. Okay, well, you could use, for example, substitution. This math is, I think it's Algebra 1 level, and I know you've all been in algebra. Most of you are in Algebra 2 or Pre-Cal. So yeah, what we're going to do is we're going to place this T with this expression. So check it out. That means we end up with 20 minus, instead of T, I put in 2A. So 20 minus 2A is equal to 2A. And now there's just one unknown, and that's A. So we use algebra to get all the terms with A together and solve for A. So what do we do here to get all the A's together? How about add 2A to both sides? And what that does is it gets rid of this term. So now I've got 20 is equal to, well, what's 2A plus 2A? It's 4A. And now to solve for A, divide both sides by 4. (20) divided by 4 is 5. And the dimension, I've been being completely sloppy here by not including the dimensions, the units here. I apologize. But it's acceleration, and the units of acceleration are meters per second squared. And so there you go. The acceleration of both of those blocks is 5 meters per second squared. It's less than if you just dropped it. If there was just a mass free falling, its acceleration would be about 10 meters per second squared. And now the next part, I want to figure out what is the tension in this string here. Okay. So to do that, I'm going to draw a free body diagram once more of this mass that's on the level table. So it's 2 kilograms and there's tension acting on it. And I know what that tension is. No, I don't. That's what I'm trying to find. I don't know what that is. I said, what about that? Well, it's 2 kilograms. And yeah, there are some other forces acting on this guy. There's its weight and the normal force from the table pushing it up. But again, those cancel each other out. They're not relevant here. So to find T, how about we write down Newton's second law? In this situation, the net force is just T. So that's going to be equal to mass, 2 kilograms, and the acceleration we had was 5 meters per second squared. So the tension in the string is 2 times 5 is 10. And a kilogram times a meter per second squared is equivalent to a Newton. So the tension in the string is 10 newtons. There you go. Problem done. And how do I shut this thing off now?